plenty of Okay, so let's start. Thank you for coming. My name is Anton. I'm from Manychat and from people team and employer branding especially. So we organizing such kinds of these events, and this is our first AI event. So thank you for coming for this debut. Several words about what is Manychat. I believe you're not so familiar with the company, yes? Already know about the company.
Yeah. Oh, Manychat team.
Yeah. Manychat team, please don't raise your heads. Okay. Several words about us. We are a leading chat marketing platform with lots of creators who trust the communication with their customers to us. We help businesses through such social platforms as WhatsApp, TikTok, Telegram, Facebook Messengers, and so on and so forth. Speaking about the team, we are global, and 300 people work here in 5 offices over the globe. In Barcelona, Amsterdam, Yerevan, Austin, and São Paulo. The R&D team and most of developers, AI researchers, AI developers, data scientists work in Barcelona and Amsterdam. And surprise, we are hiring for these positions in these locations. So if you think you can consider working with our task and our team, please don't hesitate to come to me or to my colleagues. We have Diana, the recruiter for these positions, and we have a lot of, developer guys, technical guys who can explain how it's works under the hood, and give you all the details and all the information. So you can find easily this T-shirts, or just ask me. And we believe in Manychat that everything starts with a conversation, and we just separating a lot of conversation, but also we believe that everything starts with people here. And you can check our career sites to get more info how it looks like. We just renew it and tried to give present the spirit of the company on these pages. Thank you for partnership, our partners Zencoder, which speaker will be presenting their talk also today. And plan for tonight. We have 2 talks without break. I decided not to take the break, to fit it into 1 hour and have much time for mingle, for chatting, for networking, and so on. So Kristian, my colleague from Manychat, will be speaking about implementing multi-agent system here at Manychat. And Artem Gorokhov from Zencoder will share the story how software agents coordinate to solve complex tasks. And then, as I already said, there will be networking part. We have a lot of beer in the fridge. We will have pizza in 8 p.m. So a lot of reasons to stay till the end. And you can already scan this QR code, not to forget, give us the feedback afterwards. So yeah, but of course I will be repeating this a couple of times. And yeah, let's start. The round of applause to Kristian. Kristian, welcome to the stage.
Okay, cool. We can actually, I think this is the wrong slide. Okay, nice. We can start. So today I'll be speaking about multi-agent systems at scale. Actually, this is a very high-level talk. I'll give some examples of the stuff we do, but I'll also talk a lot about agents and AI in general. I think there's a lot of ground to cover, but I'll try and keep it as concise as possible, so you can ask questions at the end if you want. Name's Kristian. I'm an R&D engineer here at Manychat, and prior to that, and well, currently, I'm also an AI product engineer. I like to call myself an early agentic AI pioneer because I started working on agents like way back. And previously, I used to be a founder in the computer vision space, but I really like language models, and I was always so fascinated with them, so it just sort of naturally just came to this. Manychat is, as hopefully all of you know, the leading chat marketing platform. We enable businesses to drive more sales and conversations and automate conversations with their users. And we do that through messaging apps. Manychat is obviously really, really huge in terms of the volume of the stuff that we process. Yeah, that's actually 1 billion, more than 1 billion messages per month. So those are super high volumes. And this means that when we work with such high volumes, all the stuff that we do with AI has a lot of potential upside. So that's exciting. The goals of today's talk really are to understand and appreciate agentic AI and what it can do, and obviously all the different obstacles along the way. Also, to cover a little bit, well, a few application strategies of AI systems. And the most exciting part, for me at least, is about the vision and where it's going next and what the future will hold. So, just to give a brief overview, I think this is super important because really a lot of the stuff extrapolates from this, and it's about how LLMs came into play and what they're good at, because essentially we're building with these blocks, even if we look at agentic or workflows. It's all the same thing at the end of the day, just in different complexity. So classic LLMs is what you guys are used to using. Hopefully, well, you've experienced ChatGPT obviously in the early days and played around with some role play maybe. So these are all about zero-shotting. So you have an A and B system where A is the user message and it's like a partial prompt. And then you have a static component to it. And then the LLM basically just responds. And obviously this is awesome because this is where all the hype came from for AI, right? We got some of the first foundational models and they were so cool. We could do so many things with that. And we started to think about, okay, wow, we can really, bring value or at least have fun with this. But because of this system, there's a lot of inherent limitation because we're literally zero-shotting the prompt. And, well, there's nothing you can do in the middle in that process. It's all like chaos, right? Statistics, it's literally random. So that's where, we came onto chaining, or otherwise called workflows. So this is pretty much just the first scenario, the classical LLMs, but they're stacked next to each other with very separated concerns. Well, some LLMs maybe are better at interpreting context, right? And then using that context in another call to generate a response. So essentially what this allowed us to do is to have program logic interact with the way LLMs generate content. And this is a very important step forward. So, for example, a lot of you might be familiar with Perplexity Research, where some of the different tools you can use and some of those apps, those are all pretty much workflows, although some of them have evolved beyond that, but I'll touch on that a little bit later. And there's a lot of popular frameworks you can use. Surely everybody heard about LangChain or Llama Index and played around with them a little bit at least to see how workflows can be set up. But this translation of program logic and being able to kind of have trees of decisions of different linear paths towards a particular goal, or maybe even branch out to different goals depending on what the user is coming with, has given us the building blocks that we need to build LLM agents themselves. So LLM agents, well, I'll call them agents, pretty much just the same thing as workflows. But there is one important distinction here, is that they're capable of, well, they're designed to create conclusions in the middle of a process, and then use those conclusions to drive other actions, all in kind of one, in the span of solving a particular goal for a user. So, and the way this would work is you would have the user message come in, obviously, as the A section, and then it would drop into agents, and we could do stuff like, first we can focus on understanding intent, and then we can focus on getting the right context, and then we can focus on solving the goal, and do that all inside this cycle, and present the user with a reasonable answer that the agent system actually thinks is reasonable. And so the main distinction here is the agentic loop, right? Because it's capable of doing these operations in sequence, of constantly making itself better, hopefully. It doesn't always go that way, but it's able to perceive, reason, act. It's also sometimes able to learn, and basically collaborate with other things in the system that are available at runtime. So that could be other agents or tools. This is all really pretty much solved now. There are agentic frameworks and systems in place that are commercially viable and people are using them. But there is a future to this as well. And I think it's very important to have an outlook on where we're taking this, because it might appear from first glance, from what I'm saying, is that we solve this, right? We can solve a goal for a user, but the problem is that we want to go further than that by being creative and having agentic systems that actually innovate in the process. Solve use cases that are not identifiable at any given point. So you can have users come in with a particular use case, and future agentic frameworks should be able to kind of work with that, not fail, right? And that's where a lot of that's where the future is going with this, and I'll talk about it a little bit as well in the vision part. So LLM agents are not just cool because they do stuff and can interact in a single process and call tools and save context or operate with various functions, but it's also the nature of the flow itself, the way agents are composed, that creates a superior outcome. So if we look at this rather dated and actually quite old graph from 2 years ago almost, this is by Andrew Ang, and it's from a paper on human eval, which is benchmarking. It's a benchmark you probably seen before. But the reason I included this is just to show how capable, how agentic flows or agentic systems actually reinforce and multiply the effect of a foundational model. So here we have the GPT 3.5, zero-shotting, and then GPT-4, which is the classic approach, right? So it just gets a user message and makes a response. And what's interesting here is that GPT 3.5, even though you can't even use it anymore most of the time, it's better than GPT-4 in a lot of agentic, pretty much all of them, all of the agentic applications in this paper. So agentic frameworks, agentic AI is pretty much a multiplier on top of the foundational model as well, which is really important to consider if we're trying to do very elaborate and sophisticated actions or solve goals which are particularly complex. However, there are significant challenges with agentic AI, and a lot of people fall into traps building agentic AI. The primary concern when we're building agents, making these autonomous systems that can sort of iterate, loop on themselves, is that complexity grows incredibly fast. Because every single element is actually not just a linear element. They can be called ad hoc by the model, right? And the effects can be unpredictable. And we actually get a lot of emergent behavior, which can be good and also really bad at times. Additionally, we're used to prompting, but prompting is such an art. I'm sure, like, if you've been doing AI apps or anything, prompting is a big pain, right? And when you're talking about agents and you have agents that interact with agents, all those prompts create these very subtle things that are really hard to track. Like one word change or one phrase change can really impact everything else in the system. So it becomes really brittle. Additionally, costs are pretty extreme if you let agents do their job, and sometimes you just have to, because otherwise they don't really give you a good result. But if you're using state-of-the-art models like Claude Opus, it can really balloon. I'm sure you guys seen some of the Twitter posts about Cursor and people getting charged like $8,000 per month, right? So this is like one of the drawbacks. But they're lucky because they outsource that drawback to the users. Additional thing is that inference obviously increases, right? Because you can't really apply agents in the same way in some apps, because people just won't wait for them. You have to do very weird things, like you have to send push notifications. There's a lot of product considerations when working with agentic AI. And yeah, just to speak to my previous points with state-of-the-art models. This is another cool, this is a cool paper I found recently. It's actually from March this year, but it demonstrates a very significant problem that a lot of people kind of don't really care about much, but it's about adversity and it's about opposition. So if you have agentic systems that interact with each other, what you can have is you can have behavior that opposes the actual behavior that you want to or expect to see. So if you have, let's say, one big agent that's working on, I don't know, one particular task of booking a person into a flight, and then you have one agent working on booking a person into a taxi, let's say. This is a bad example, but they will conflict with each other, right? And all of these behaviors are super hard to track. And if you're building an agent that has a lot of tools, good luck kind of breaking it down and finding how to make it work. And actually in Manychat, one of the first experiments we did with agents, we kind of fell into this trap where we tried to have one agentic system do everything. And what happened was we couldn't, like, it worked, but sometimes it didn't, and we couldn't really understand or track and actually reason on how to fix problems that caused the behavior to become erratic or chaotic, unpredictable. So we had to scrap that. And yeah, but this all sounded really bad, like it's impossible to do, but really it's very possible today. And the way agentic AI can be set up is actually by just sticking to simple things, you know, building simple. A lot of product managers try to build products like that, you know, constantly asking you to just build a prototype. Well, here it works the same way. So we have to build single agent workflows before multi-agent systems and sort of chain them together. This is the best approach because it allows us to constrain agents to work in a particular and highly defined domain of action. So you would have one agent that's, hold on, I have a section about this. Yeah, it's a bit later. You can also, at the start, use human in the loop. This is a very good approach. It's hard to set up, but it's very useful. For example, if you have contacts and you have to verify that some parser system, you know, obtained the right information about a particular contact or address or something, human in the loop can really help kind of build that experience and understanding of the data and context. And once you have all those very constrained use cases set up, that's when we can actually expand into autonomy. And together with good observability, this is actually something that we can, you know, maintain in the long run, which is the big hurdle with agentic AI. So modular reasoning, when we have agents that are set up correctly, results in scalable agent systems. And I will give an example. So, for example, you have a product expert agent, right? Something that has tools that can access the product database or go to documents, right? Documentation for a particular business, let's say, and can decide what info to retrieve. And then you can have recommendations from that. And you can have an order management agent that has access to CRM, order systems, shipping APIs, stuff like that. Very, very concise in terms of how they're applied. And you can have billing agents as well that can do, like, you know, chargebacks and bill people, things like that. And we can build all of those components as separate components, track them separately, have separate prompts and all that, and they're completely separate components in a system that acts as a whole, as a bigger thing, right, than the individual parts. And the way to actually make it work, if you have those components, right, we have this question, okay, so if we have this separation of concerns, how do we actually have this whole work together? And one of the good things that really helps is having a gateway. And the gateway is basically an agent that kind of understands the state and understands the entire system at any point of time. So when the user message comes in, it's able to kind of route the user request into an agent which is the most suitable for a particular use case that the person is coming through in the product. And then all the agents can iteratively work together. If they fail, they can tell the gateway that they're failing, that it's not really the use case that the user is coming for. And in an ideal case scenario, what this will result in is basically just longer inference times for the user. But they shouldn't be able to see that things are falling apart. The gateway is the orchestrator and also the filter. This is the most exciting part for me personally, because I like to think about this all the time. But it's about where we're headed, and it's about future of agents. At the end of the day, no matter how well we compose the agents, we always hit a ceiling. And this ceiling has been moving quite rapidly upwards because a lot of money is going into this, right? It's about compute, about how to decrease inference costs and make inference faster. And that's basically the driving force for agents. All of this would be impossible and would fall apart if not for great models that we're seeing today. So models like Gemini 2.5 Flash recently come out. A Llama 3.2 series, my personal favorite. They're better, faster. They really don't require a lot of money to run. They can be easily tuned because obviously they're smaller parameter. And if we look at the example previously that I mentioned, individual smaller models can really kind of leapfrog over state-of-the-art models if set up correctly. There's a lot of models coming out. NVIDIA is training models in particular for agentic action and chain of thought. And we are seeing increased context windows that make RAG obsolete, for example, but also allow agents to operate with very large context when necessary at low cost as well. So future of agents is basically driven by the foundation, and the foundation is always going forward, and we can expect very, very good models next year for sure, much better than what we have today. And this is just a thing that kind of goes further than that, and we should think about when we're building agents, what are the agents going to be like as a premise in a year or two and in a decade? And this is something Sam Altman said once, actually many times, at pretty much all of his podcasts and stuff, is that we're pretty much done with chatbots, reasoners, and agents. Right? Agents are, if you do them correctly, you can set them up. But we're really not done with innovators, and full organization is kind of sci-fi at this point, but innovators is where it's at next. And innovators really are a challenge because they make us think very creatively. The agents, they solve what the user is asking for, and that's not always what the user actually wants. But the innovators, they're actually about solving what the user wants or needs at any given point. And it's not just about the logic of how we set it up, the system. Well, actually it is, but it's not so much about, there's no magic to this, really. It's about having the agents increase their core capabilities into proactive understanding of the user at any given point, proactive understanding of the issue. So if the user is coming to you with a support question, he might be thinking that it's a support question, but really we can sell him stuff, stuff like that. So it's about having the agents act as creative entities, or like human agents would act in a certain context. And it's about knowledge synthesis. It's really all about context and working super well with it, grooming it and housekeeping. Why I'm saying this is that when you're building agents, context is like the number one thing. If you have bad context, everything falls apart. So whenever you're setting up an agentic system, like one of the first questions you should ask yourself, well, I certainly ask myself every time, is what should we have in the context? What are the parameters? What information can we get? Can we interface with user calendar, email, or something like that, for example, right? I'm just giving examples right now. But it's about systems that learn from your environment and not waiting for you to tell what's important. And obviously, all of this builds into emergent behavior, because we like emergent behavior, because LLMs are all about it. You know, you do stuff, and then it makes these wow moments, and that's what really creates the hype in AI. So that's it for the slides. Yeah, this is a closing remark that 2025 is still strongly about agents. I actually wrote this slide in 2024, but yeah, we're still there. Thanks for listening. I'm ready for any questions you guys might have, and I'm just going to leave another slide with my QR in case anyone wants to kind of connect on LinkedIn. Thanks.
Thank you, Chris. Guys, do you have any questions? Feel free to ask. Using the microphone this way, because we are streaming.
Yeah.
Hi. Very nice talk. Thank you.
Thanks.
The question I have is, you mentioned your favorite is Llama 3 series. And I don't know if you can answer this because maybe it's part of your research, but what is the smallest model in terms of billions of parameters you managed to use to get something useful in terms of agentic AI?
Okay, so I used the 1 billion parameter model, and that was cool. Like, so for some very small tasks, for example, determining whether you need to route a particular user in very distinct intents, like a very binary classification task, works pretty well. But obviously, it has to be kind of supported, right, by few-shotting and good context. But Llama, yeah, definitely are good.
Nice. And have you used any reasoning model for agents as well?
Yeah, only recently though. I've used reasoning with Claude Sonnet model with the reasoning on. That works really cool, but I've noticed that, for example, for R1, for the DeepSeek model, the reasoning was just, again, it's about this adversity. So reasoning creates a lot of uncertainty when a model is generating a response, which can make the behavior very inconsistent, especially in high temperature environments when you have a high temperature setting and a very complicated context. You can have the model confuse itself, where the non-reasoning model will not confuse itself but might produce a less verbose result, something a lot shorter, maybe not so valuable. But in general, reasoning models are not so, they're good for role play and things, for classic applications, but they're not really good for agentic systems, in my opinion.
Yeah, makes sense. So basically you're saying this is about constraining the things to the right context
Yes,
and the right
of course. Then that comes with experience, obviously, and reading.
Thank you so much.
It costs a lot as well, yeah. Because reasoning tokens. Any other questions?
Yeah.
Hi, thank you for your presentation. My name is Oля, and I want to ask, you mentioned that you used to have only one agent, and then you moved to several agents, more smaller. And my question is, did you face with the problem that maintains prompts for several agents takes a lot of time because models change and sometimes you need just to rewrite sentences? And where is a balance? Where is better to keep one agent, but it will be easier to maintain, and where is better to split agents and spend time for prompt tuning for several models?
That's a good question, actually. Prompting is something I don't feel very confident talking about because it's very unpredictable. But I'll try to answer your questions. Actually, I just feel hopeful that at one point we don't have to prompt anymore, but then my job is kind of obsolete. But really, maintaining prompts is just something that we have to do. If you have very specific domain agentic systems, the prompts can be super compact so that they can be very reliably transported to other models or used with other models and maintained throughout time. But that's in very particular context, right? So as I said, very simple agentic systems. But if you have a massive agent with like 100 tool calls, let's say, right? And then you have different ifs and adversity statements where you know, you have if the user is asking, and you sort of reinforce the prompt, that can become very messy. I would say in order to have the prompt as dynamic as possible, it's necessary to avoid writing prompts with examples, for example, right? Because examples are very about particular state of a system, and then you build a system, you move to another model, and the generations are different. So the examples really introduce uncertainty. So just use general text, try to be as applicable as possible to whatever use case it's doing, and try not to add, like think many times before adding something to a prompt, for sure. Because then the complexity just becomes harder and harder to maintain. Not sure if this answered your question, but.
No, more or less.
Yeah, thank you again for the talk. My question is more on the multi-agent paradigm. When you are talking about multi-agents, is really a multi-agent architecture where all are independent, they collaborate and communicate through some messaging protocol, or we are talking about a composable graph with that direct acyclic graphs? This would be the first question.
I would say I talk about graphs mostly when I'm talking about agents. I didn't touch on MCP or ACP or whatever it's called now. I didn't touch on that because honestly I haven't had enough time to actually experiment with it myself to draw some conclusions about it. But I think it's kind of the same thing. It's just that it's all about building. I think it's about just adding another layer of abstraction, because agents communicate anyway, well, through text, through output. But ACP, for example, is just a higher abstraction above that, where you can have a code block and you just plug it in, whatever, and it goes into the interface, right? So, yeah, I haven't had a lot of chances to work with that yet.
Yeah, so my question was more like, in the end, yeah, it's an abstraction. I was more curious about the complexity when it comes from these like composable agent graphs to a really multi-agents that communicate, and all of the observability you talk about, how this could increase in complexity, especially on the dev side of the things.
It might, but I can't really see how. I think it's a good thing, because a lot of the problems are like when we forget to set up observability in the correct place, or if we engineer architect the communication between the agents in the wrong way. There's a lot of refactoring that you have to do. If somebody does that for us, that's great. I mean, I'm all in for that. If there's a repo that is very popular, has a lot of stars, I'm definitely going to play around with it. And if it fixes and it's stable and it's maintainable, and it could be, I can see the opportunity there for sure. I mean, definitely try to experiment with that. But I think it's important to have the base understanding. Try to actually build this communication between agents on your own before using a framework like that, just to have a better overview of what you're doing.
Yeah. Thank you.
Well, a lot of questions.
Hello.
Hi.
Thanks for the presentation. I have a question regarding the innovators. So it looks like the agents are working on a common knowledge, but innovators would rather require some personal context. And my question is about how do we collect this personal context to anticipate the questions, and who is gonna pay for this background work? I mean, what's the financial model here?
Okay, good question. Well, I think the market is going to force those that are building agentic AI to pay for them, for agents, because at some point competition is going to do that. The innovators, well, enrichment of the context and all that, and everybody has to follow, in order not to fall out of the market. But answering your question regarding context collection, so there are things that are possible to get from the system, obviously, and there are things that are not, and getting those things that are not is essentially filling in blanks in the context by very good understanding of the context that there is, and understanding of what to ask the user, or how to interrogate during the conversation to fill in the context blanks that are missing, right? And then doing sophisticated reasoning on that to offer solutions and actually identify what the wants are or the pains of the user, rather than having him actually spoon feed the system. So I think it's all about the conversation, really. Language models are a language, and it's about interacting in terms of the medium of the language with the users. And I think agents have to do more of that.
Hi, Kristian. Thank you for the presentation. I have a question regard to agentic systems. Like, you described them as a system which can act proactively, if I get it right. So I could just, can you mention any, like, your personal favorite cases where is agents works proactively and you find it useful in real life for you?
Good question. Actually, I've yet to see agentic systems that are proactive in a way that I like them. I think this is more of AGI territory kind of thing, where you have this general intelligence that kind of wants to get you across something, right, to bring you value. I don't have any real life experiences. I've used a lot of apps with agentic systems, but couldn't see any of that behavior. But if I was to give an example, right, imagine you have a, this is not related to Manychat in any way, but it's something that a lot of us can relate to, I guess. Imagine you have a meeting and you have emails and stuff, right? Obviously you can have the LLM just read your emails and prep you for the meeting in a very general way, right? But the innovators, like the proactive agents, right? But the proactivity element would add to that, that this agent can ask you questions proactively, like, okay, you got this meeting coming up, but who are you, right? Because I don't understand from the emails. And then you give all of that information to the AI, and it's capable of just not giving you a brief, like you have a meeting with this guy and you had emails about this and that, but it will tell you, like, okay, this is a very important person that if you, close the deal and whatever, it can give you connections to something. So this is an example just off the top of my head. But I've yet to see these, and I think at the end of the year we'll have some systems like Perplexity will surely do that, or ChatGPT, and it's just a matter of time.
Cool, thanks.
Let's have the last one.
Thanks for the presentation. My question is related to prompt engineering, actually. So you said that prompt engineering is not the best approach if we are dealing with a lot of agents. So, like, my question is, what is the best way to approach this problem if we're dealing with, let's say, at a very large scale of agents?
Yeah.
Like, just to not go into the prompt thing. Like
No, that's not possible. I mean, you have to go into.
Like we are providing the prompts, but like, as you said, that it can overlap. Like some agents might have some if-else situations, and the other might contradict this.
Mm-hmm.
So how do we solve that issue? That's my question.
Okay, it's really about design. So the prompts, before you write them, you have to kind of really design really well what's got to be in them. And when you think about all the prompts you have in your system, you have to review them, I don't know, manually or using another LLM to make sure they don't overlap as much, so that if they're actually running in the same runtime. But really, prompt engineering is going to stay. I mean, it's why I like language models. There's a very creative element to them, right? But you have to have good observability, and then you have to have the ability to set up tracing in a way where you can rerun this particular step of the agent to just tune it on particular use cases, right? In this very isolated environment of just this one action. And then hopefully, if you've done everything correctly and designed the system well, you won't be seeing weird things happening, although they will still happen, but it's just about separating concerns and make sure your observability is really good and iterate on data that you collect during the system runtime, change some words, I don't know, work on the prompt as we all do, like manually. You can also use prompt training, like the SPY and stuff like that. Personally, I never had any success with that. I don't know how people prompt train, really. If somebody can tell me, that'll be great. But yeah, just keep things simple, separate concerns, high observability, nice data sets for testing, and you should get there.
Thank you, Chris. Thank you guys for the questions. Chris will stay with us for a bit after the second talk to chat with you. Yeah, if you have any questions, or we will be having some, please address them. And I want to ask Artyom to come and yeah, thank you. All good?
Okay, yeah, I can say something.
Are you ready?
Okay.
Okay,
So do we
round
wa-
of applause for Artyom. And his talk about agents.
Yeah. Hello, everyone. Thanks a lot, Kristian, for your presentation. You actually helped me a lot establish a lot of the baseline that of what we gonna talk about, and I believe I'll refer to your talk at a couple of points in mind. So, my name is Artem, or Artyom in Russian, and I'm a team lead of the agent platform team at Zencoder, a coding agent AI startup. And today I wanted to talk about how software agents coordinate to solve complex tasks. The working title of this talk was actually more like how to build a multi-agent system for your software development using tools you probably have at home, but it was too long. Corporate cut it. Okay, so a couple of words about Zencoder, why we have actually an opinion on this matter and why it might or might not make sense to listen to us. We're building an industry-leading coding agent platform. We're providing coding and custom agents as in our plugin for VS Code and JetBrains. We have an early access offering of autonomous agents in CI. We can provide you with a multi-repo context, so for the organizations that have multiple repositories with different microservices, back and front and whatnot, we can actually provide the agent with the context across all these repositories. We have multiple integrations with the tools you already use, Jira, GitHub, other repository providers, Slack, whatnot. And yeah, they asked me to put a cool fact about us. I didn't have one until recently, but so I'll share it now. Just an hour ago, our PM messaged me and said he used Zencoder to set up local dev environment for a project, code a feature, fix some bugs, fix some CI checks in an hour and a half. I think that's pretty cool for a product manager who didn't have any experience working on this product before that. Okay, and we also use, I have to admit, we use the Zencode as a verb internally. So we can say this product manager Zencoded a feature. And so, as I mentioned, thanks a lot to Kristian for actually establishing a baseline and making sure we're all on the same page of what agents are. But I just want to give you another refresher. So, as you know, the usual LLMs is just one single request that goes to an LLM, gives some output. When we go to the agent, we get an agentic loop, a feedback loop that lets the LLM reason, lets it call tools, lets it feeds the result of the tools back into the LLM, and this feedback loop leads to better context that goes to LLM, better results, and lets it interact with the environment, giving us a much more powerful tool. Some examples of what these kind of tools can do in the software development world. Most of them coming once again from a product. Well, you got your base coding agent that writes that can write features, fix bugs, do refactor, whatever else you ask it to do. You can have a review agent that once again uses tools to analyze the code in your PRs and to actually submit comments on your GitHub. That a testing agent can once again reason about your code and call Playwright to record how your app actually works and generate tests, etc. And why, if you can see here that once again, as Kristian said, all these agents are very domain-specific agent. So why would you need domain-specific agents, and why sometimes one single domain-specific agent isn't enough? Well, there are several quite obvious limitations that wouldn't allow us to use a generic agent that can do all your work for you, whatever you ask it, that would be able to just take a huge task as a dev would do everything you need, analyze it, test it, whatnot. First of all, we got the limited context window. It's very hard to hold a huge context in memory. Like, you know, software projects can be enormous. They can span multiple repos. They can have mono repos consisting of thousands, I don't know, hundreds of thousands of files. You can have different project setups. It's very hard to reason about in a single context window. And also the coding agents of today, they have to complete the task, they have to actually have huge trajectories. They can call they can execute 10, 20, 50 tool calls. It's very hard to, once again, to fit into the context windows of the models of today. And also, each agent requires different prompts, different tools, different types of context engineering, everything else. So in order to work on a huge task, in order to achieve some very good result, you need to make agents collaborate. And today I wanted to talk about a very specific way that once again you can make agents collaborate once again with the existing tools without fancy agentic frameworks, without anything. And this is running agents in CI, and how you can use this to split up work between multiple agents and automate it, and some patterns that you can use in your multi-agent systems. Like that. That's what we do here at that's what we do in Zencoder. You have some external trigger that triggers your CI action, like a GitHub action, whatnot. And in this action, you actually run some kind of an agent that has access to your development environment, because it's running in CI. You already got this setup, right? You got your checks, you got your lints, you got your tests, build, scripts, pre-commits, whatever you guys use. And with this environment, the LLM can interact with your tools exactly in the same way as a developer would do, or as a regular check will do. And the result of this can be a PR that you can merge in your code, can be some comments in the PR that you or someone else created, and anything else. And this is a very powerful foundation for building multi-agent autonomous agent systems. So what else can you do here? What can you do here? For example, let's say we have a ticket and we want our autonomous multi-agent system to work on that ticket, but we have a problem. We have 3 repositories. Each of them has their own CI. Let's say we have backend in our project, we have frontend, we have mobile, and we have a single ticket that, let's say, implement a feature across all of our tech stack. How do we understand that which CI agent out of those 3 repositories to call? Or maybe the change needs to be done in several repositories. We can, first of all, just using some kind of a automation like a webhook, send the task to a planner agent that will analyze the task description. It can have access to the repository context. It can be basically just a list of your repos with some information what is in each of them, or it can be a code search that will allow it to understand better something that is not present in this information. It then can split the task into several subtasks. It can call the coding agent in the backend repo, in parallel the coding agent in the frontend repo, and like if you have a mobile application, it can also code a mobile application for you. The same can be done if you have a mono repo. Obviously, you can have 3 agents working in parallel, submitting 3 PRs. And then each of them will do its work, and you'll just have a full feature coded in parallel. Yeah, and then what happens with each of those PRs? As you probably know, the agents don't always output the best code out there. They make errors, they sometimes don't follow the best practices, they can do some weird stuff that will make your company lose a lot of money, which we don't want, right? And what we can do is we can have the coding agent submit a PR, then once again call a via GitHub action. We have simple automation that will have in our repositories, run a review agent that will review this PR, and this actually can improve the quality, because having a second pass, even of the same LLM, review the code can really point out the deficiencies in the original version. Then the review agent will leave comments, and we can press the changes requested button. We can also leave some comments on our own. We can, I don't know, pick up the CI checks, and then it all goes back to the start. So there's a loop, a larger feedback loop. You know, agents are already feedback loops. So it's a feedback loop of feedback loops, if you will. That will actually, after a couple of iterations, can really improve the quality of our code. A small detail that, as you see, I put changes requested here, because we don't really want this loop to become infinite. We want to stop this at some time, so I keep on here that at least now this is kind of a human in the loop thing, that for now it's still best to have the human actually decide if the requested changes need to be sent to the follow-up agent to fix them and go on. So this, we can see 2 patterns emerging here. They are very simple. They are more closer to the fixed workflow patterns than to more advanced stuff with agents calling agents, deciding when to call agents on their own. But oftentimes the simple stuff works the best. We can have a planner agent actually split and route the work between multiple agents. You don't have to just to use it to decide which repository a Jira task needs to be fixed in. You can also have, if you, for example, build in a documentation or rebuild in a documentation for a huge project, then you can have the router split the task of building documentation into several sub areas and say, hey, you go to this part of the repo, you document this, you go to this part of the repo, you document this, etc., etc. And then we can add another stage to merge these documentations to generate the final doc. And the second pattern that we've seen, once again, is a pipeline or a sequential workflow pattern with a simple agent handoffs. Once again, this is definitely not the only use case we can see for this. We can start from requirements and have the agents drill down from the business requirements to the technical requirements, then next agents picking up the technical requirements and build an acceptance test from it, then the next agent actually writing the code until the acceptance test passed, etc. And I'm pretty sure you can come up with a lot of examples on your own. Yeah, so just two key insights. You notice I didn't have a lot of insights, so I had to make the fonts really large and the space really huge. So reuse stuff you already have. That's down to one insight now. If you have automations in your business, in your code area, if you have GitHub Actions, Bitbucket pipelines, webhooks, Zapier, whatever else, Jira automations running, you can use this to connect agents. And the second, run agents in existing environments. Once again, you have CI workers, you can run agents in the CI workers. You can you use code spaces or some other development environment as a service, as they call it now. You can run the agents there. And by combining these two, you can build multi-agent tools with a multi-agent system with the stuff you have at home. And you probably already have an idea of how this multi-agent system can help us developers. Well, it's basically the next level, because we already see coding agents giving a huge productivity boost to a quite large part of the developing the world of development. And when you go to the collaborative system, you can basically solve more complex tasks. You can solve those tasks autonomously, automating your tedious work. You don't have to. You can have a multi-agent system collaborate to fix a dependency, a security issue over all your code base, or to perform a huge language version, framework version upgrade. You can have all this running in parallel, like multiply, scaling your productivity from 10x, 100x, and hopefully in the future. Probably we're not there yet. And we have, obviously, with the context tools that we make available for those multi-agentic systems, like to make them actually collaborate over multiple repos. You don't have to switch context between repos yourself, and just focus on higher level tasks. And the next question is, how does this impact us in the other way? I'd like to talk about the future a bit, because all those systems are evolving rapidly, and the fact no one knows which no one can tell you which impact we'll have. We're building coding agents, and we have no idea. But what we see now, what we see in emerging, every dev becomes effectively a team lead, leading a small team of coding agents that can collaborate within that, and you will be building agent pipelines to make you and your team work more efficiently. You will use a lot of AI tooling. You will use probably something more advanced, going more into the autonomous territory than what we have now. I think a lot of, well, you know, there's codecs, there's cursor background agents, and there's obviously our Zen agents for CI that you can request early access now to actually, and we can actually show you how it's all built. So please contact us. And I guess that's it for my talk. Thank you for your attention. Our team will be here to network, so please, if you have any questions about the product and anything you want to talk about, please come over and connect. We'll be happy to see you.
Yeah, thank you. Thank you. And we have time for questions. No, Chris,
How much Zencode do you use to Zencode your Zencoder?
I'm pretty sure this is under NDA, but I can tell from my personal experience, sometimes 90%, but I'm a team lead already, so.
Nice, that's good.
Hi, sorry. Hi, my name is Dima.
Hey, Dima.
So, yeah, hey. So when agents communicate, there is a problem that they can generate like a lot of tokens, right?
Yeah.
And how to approach this problem without losing the context? Like to decrease amount of tokens, but at the same time deliver the best context there is?
That's a very good question. Context engineering in general is one of the most important fields right now, and in multi-agentic systems more than ever. Here I think it's quite the main reason, the main way to do this, especially when the agents are communicating via CI or via existing workflows, is to have them generate artifacts that contain the information and do actual prompt engineering, spend some time iterating to make sure these artifacts have the most detailed information without any fluff. So a good information to slope ratio. It's kind of similar to what like the emerging MD format for repo MD, etc. Because like Claude.md cursor rules are in effect the ways of agents communicating between themselves. It's one agent storing the information for other agents to use.
Hi, thank you for the presentation. I'm not sure that my question is correct, but we'll see. I understood that Zencoder help us with CI/CD, and for me the most annoying process is before CI/CD is merging conflict in Git repository.
Okay.
And does Zencoder help with it? And if yes, how it works? Because if you're using AI agents for code generations, it likes to change single lines in some random place for something similar, but sometimes it acts differently, and it refers to a lot of merging conflicts, and how Zencoder can help with it.
Okay, I have a hypothesis. I'm not sure. I think someone from our team has actually tried it, but I'm not sure. But merge conflict is a file, right? So you have a file with those special markings. So you can have a custom agent. We have custom agents, as I mentioned. That's basically some instructions that you can give, and you can instruct it to actually solve merge conflicts within a file. And for example, one pattern that you can use is actually run this custom agent with this custom instruction to solve merge conflicts in your CI CD, and when you hit merge and there's a conflict, it starts and just resolves this conflict, generating the correct PR. It would be one of the ways to make it resolve conflicts better would probably be to give it a Git tool, so it can view the branches and understand where both paths of the conflict come from. So what makes sense to keep, what makes sense to leave. So yeah, I think we have we do have a Git tool available. So yeah, you can try. And if you try, let me know how it works.
Hello. You're mentioning about the human in the loop and the fact that a human will need to approve the change in order to go further to the next agent, one of the diagrams. And I'm wondering if there are any policies to request a different human. For example, if one person commanded one change, it might be that the whole command started wrong, and we would like a different human to review it. The same way how today we're doing with code reviews, I believe in these specific systems, we need at least two humans. The initial one that commanded the work and the second one that approves the changes of the LLM. Do you have this plan or?
Yeah, well, once again, we're using existing systems here. So what we can have, if we can have the Zencoder user that performs the action on behalf of the LLM. We can have one user that comments and one user that approves. Right? That's what you're saying.
So initially, the task started with a human. When they created their task somewhere in a different system, you integrated with that, and the agent started to work on it. Then the same human can come and say, I approve this change. But probably you want a policy to prohibit that stuff, so that the initial trigger human is different than the final human, and only your system knows about the whole environment. So basically, I cannot implement a policy in GitHub directly because the GitHub won't know who initiated this specific operation, because it will be your agent user that published the PR, I'm thinking.
Okay, so first of all, you don't have to create a separate agent user. Right now, I think the best way to deal with it would be actually to pass your token and have the agent create PRs on your behalf, if you're fine with that. Not everybody is. But yeah, I think you can once again use automation tools to set up some policies like this and probably sync the user, for example, from Jira. If it's linked with a GitHub user, you can just sync it and make some kind of a comment or a rule. Like, for example, with the GitHub Actions, you can have conditions and you can have policies in GitHub. I can't probably write you a policy or a action right now off the top of my head, but I guess with some kind of clever scripting, it should be easy to do depending on how your corporate environment is set up.
Thanks.
Thank you. Who else? Just a minute.
Hey, thanks for the talk. I haven't used Zencoder, but I will give it a try. So you mentioned the importance of context, right? When you're managing multiple repositories, you have microservices and stuff. How at Zencoder or at similar solutions, you are keeping track of all the connections between different components of different like subsystems or repositories? Perhaps graph type embeddings are important in this case?
That's a very good question. So I believe it's still unsolved in the industry at large. I can say that we experimented with some approaches. Right now, we're basically using repo descriptions. So like basic cloud.mds of our version of repo descriptions that the agent can actually look into how it connects to other repos. One of the things that, it's possible to do, one of the things we tried in some experiments is building graphs or building maybe C4 system of describing actually computer systems where they go from system level to container level, etc., and using the documentation generation approach that I mentioned, we can generate the C4 diagram for the system, for example, and it will have a graph, basically a graph with the system, how the components of the system interact within, how the smaller level components within each component interact, etc. And this can be useful for the agent to understand the whole picture.
Yeah, let's have the last one and have much time for conversation after the talks.
Hello, thank you for the talk. So I never, I only used VS Code with Copilot. I don't know what is Zencoder capable of, but I wanted to ask, like, if I start Zencoder in, let's say, a folder, right, where I have my code and my data in a Excel format, is Zencoder able to also access this Excel data? Because I work in healthcare and, you know, I have some sensitive data that I don't want the IDE to access, maybe.
No, I'm not sure we support like XLS data right now. Probably if you export it to a CSV, yes, then definitely.
So for instance, if I do like df read and then I do df.head, Zencoder is gonna be able to access it, and then is it gonna process this data into an LLM?
Okay, yes. Well, of course you can limit that.
Yeah.
Yes, and we have zero data retention agreements with the LLM provider. So if you're on a paid plan, I don't think they shouldn't keep your data. On a free plan, you know, anything goes.
Okay, thank you.
Thank you, Artem. Applause, please. Yeah. Thank you for being here. Yeah. Thanks. I will show you a couple of slides in the end, if you don't mind. Of course, it will be the feedback form. So prepare your phones. Let's start. Number 2, round number 2. No, 5 minutes for your feedback, please. For us, it's very very delicate moment because it's like the first event here in terms of AI, and we kind of thinking, do we want to continue? Is there any demand in Barcelona for such kind of events, for such kind of talks? So please feel free to scan this QR code and leave your thoughts regarding the particular talks and the event generally. If you want to share something with me, like personally, feel free. We will have like 1 hour and a half or even more with pizza, beer, and conversations, because we're here for conversations mostly. And once again, thank you for coming. I believe we can meet each other in autumn. Here is the last, I believe, meetup in this office, because we are moving in a week in some office which is like bigger, more cozy, more like comfortable at all. So hopefully we can see each other next time in the new office. And thank you. Let's go to pizza and beer.